Hello, it's What the Doodle here, and in today's session I wanted to go over an article that I read yesterday, and it's by Matt Hodges, and it's called "CSVs are kind of bad and DSVs are kind of good," and he pretty much nails it in the subtitle of it, where he says, "I would simply use delimited characters to delimit data." And obviously, I'm not going to go through in detail in terms of this article, but just sort of a high level so that I can really just kind of see how the parsing would happen in Rust, for example. Uh, and the important part of it really, essentially, the CSV, the issue really is around, or the issues with CSV is essentially schema definitions. That's what it boils down to. Because when you have a data exchange format, you have to have a defined way of encoding or a schema that how you exchange that format. How you exchange that data between two different parties. So you need a schema in order to be able to correctly encode that data, and then on the other end, you need that same schema, or you need to know what that schema is in order to decode it. Now, CSV on the surface sounds like a very simple data exchange format, and it was supposed to be. Unfortunately, there's so many different variations, and none of that, the decoder cannot know that ahead of time, because it all depends on what options in terms of the encoding that are used. And this is why we have that issue with CSV. And in fact, the issue is so bad in one of the solutions in Python, well, at least, and certainly perhaps in other languages and frameworks. In Python, they have this thing called the sniffer library, which essentially tries to deduce what those specific options are in terms of the CSV encoding. And many programs like LibreOffice and Google Docs will do a similar kind of auto detection. And of course, that doesn't necessarily mean that the detection will be successful, in the sense that it may think that certain options are chosen and those aren't the correct ones, and in which case you get essentially the data that's imported or decode, if you like, is incorrect. However, as the sort of the subtitle of this article, he essentially talks about using ASCII characters, and these are non-printable characters, so they don't actually appear if you were to open a text file, you would not see them. They are control characters, so they are sort of invisible, but they are there. And it goes into more, if you actually follow the link and go into those control characters. There's 4 of them that have been defined, in various levels of ways of separating things out. But the ones we're really interested in are ASCII character 31 and ASCII character 30, and these essentially replace the comma, if you like. So 31 is the between fields of records or members of a row, and then at the end of a row. So really, those are the only 2 control characters that we really need, to be honest, to be able to replicate all of the functionality of a CSV. So with that said, if we let's boot up a terminal, and let's make this a little bit bigger so you guys can follow along. And what we'll do is we'll create a new project. We'll call this DSV. Let's jump into that folder. Let's close that terminal, we don't really need that anymore. Let's open up our little terminal. Let's clear that. Right, so if we run this, that's fine, it builds. And as I said, in this particular, if I go back, in this Rust session, we don't really want to have a look at the encoding half of it. We really want to have a look at the decoding aspect of it, and we want to decode using specifically 31 and 30, which are sort of the comma and the new line, and these are the ASCII command sort of characters, or control characters, as opposed to sort of visible renderable characters. So if we go back, so let's create a function. Let's say parse data, I don't know, something like this, and what we'll return is essentially a vector of vectors, or vector string. We need a few mutable variables, as we parse it and build up the structures. So let's do parsed something like this. So let's initialize that. And we'll also need one for the row itself. So let's call that row. And let's see if that parses. Let's see if that compiles. I am missing an angle bracket here. Yes, it compiles. Brilliant. So what we need to do is essentially just iterate over this. So we'll iterate with an index. I like to call that IDX, and we'll turn that into an iterator, and then use the enumerate function. Does that compile? Yeah, that's fine. Okay, and so what we'll do is we'll have a look at the item, and if it's not empty, so we can do that by just checking the size of it, and also if that item, so we know that item isn't empty, so if we look at that first element, is that essentially equal to the sort of comma separated equivalent control character? And in that case we want to do something. Otherwise we'll come back to that. Otherwise, if the item length, so it's not empty, and the item, or that first element of that item, is equal to 30, which is the new line, we'll do something else. And finally, if it's none of those, if it's the actual data itself. So that's kind of the actual top level logic. That's all you really need. Let's see if that compiles as well. Yes, that does. So essentially it's really these two different things that or the three code paths, if you like. So when it's a particular item in that whole row, when you've got to the end of the line, and when you have the separator. So really, we can say when we have the separator, we kind of want to skip that control character. So what we can do, something like print line, and we can say something like I don't know, unit detected, because we don't really need to do anything, and we're just skipping right past that. When we have essentially a new line, if you like, what we'd like to do is we want to actually push the we want to actually put the whole row, if you like, and we'll need to clone it we'll need to clone that, and we'll also need to actually clear that particular row, because this is at the end. So it's, we're coming to the end of that row and onto the next, or end of that record, and we're going to the next one. So we're going to push it into this temporary vector that we're building up, and then each of the rows we're clearing it so that it's ready for the next set of next. And of course, when it's we can obviously, I don't know, we can just print that as well, just so we can say that new line detected. So yeah, and then of course each of the units itself we want to push into the row, not the parsed, which is the sort of set of records, if you like, but the actual individual row. So we want to push into that one, and what we're going to push is essentially a string, because it's that's what returning back is a string, a vector of strings. So we can just to make things simple, we can say something like from UTF lossy, because we don't really want to worry about sort of encoding and decoding and all that kind of stuff. So we will lose precision, and it's not perfect, but this is only just an example. So we can do some. We can then turn that into an actual string, and yeah, let's see if that actually compiles. That does. Okay, let's format this a little bit. Okay, fine. And get rid of that. So really, that is it. That's the actual decode part of it, and we can probably do an example of this. So of course, let's run it as an example because we know this would work, assuming that you can load something from disk or somewhere with these characters in there. This would then give you back a vector of strings. So what we'll do, we need to define, and this is just we need to define a few things. So let's define the unit itself. Now, what we'll do, we'll use unsafe for this because when you create the char type, a control character, we don't use that. We want to use unchecked. Of course, we could use. We could use unwrap for this, to be honest. But what I want to do is that, and then if I copy that, I'll explain sort of in a second. So we've got the units, and I'm going to do the row as well. The row is 30. So so the unit is each of these commas, if you like. The reason we're using unsafe, let me just see if that still runs, still compiles, sorry. It does, which is fine. So the reason we're using unchecked is because otherwise you have to do a whole lot of, in Rust, because of the safety, you have to make sure that the, normally you'll get an optional back, and so you'd have to sort of check to make sure that you haven't got an invalid, and in for production code, that would be the right way to do it. But in this example, because we know this is going to be valid, and we are 100% sure this is valid, we are essentially marking this entire thing as unsafe, but we're kind of saying to the next person or the next developer, that we're 100% sure. We take on that responsibility. Of course, this could be an illegal value, but we know it's not, if that makes sense. But because it's demarcated explicitly in the code base, you can imagine if this code base was millions of lines of code, then we know explicitly exactly right here that this needs to be checked, this needs to be fully confirmed that these values are correct, because this is a potential where you could have an invalid value or an illegal value that would cause undefined behavior. And of course, there's the other way around from here. If I didn't use unchecked, for example, I could use unwrap, and that would be a shortcut. But again, that's also bad as well, because that could panic and so on and so forth. But for our case, we don't need to worry about that, because we know 100% that 30 and 31 are valid inputs to this, and this will generate the correct char type for both our unit and row. So we can use that, but we have marked it. Of course, there are other ways of doing it. So let's create a mutable DSV type. Let's just say that's a vector for now. So we initialize the vector. Let's create some data types, or let's just create bits of data. Let's say Bob. I don't know. So we'll do Bob, and we want the actual bytes. So as bytes. So we've got the Bob byte, and then we can then push that into our data, into our vector. So we push Bob there, and so let's create our first delimiter, and that's basically our units. Sorry, it's going to be a vector, and we want the unit as U8, and DSV.push, and we're going to pass in the delimiter. So let's create another value, maybe the age or something, I don't know. Let's say the age is 23, again as bytes. And we're going to push that into our DSV structure. So let's push that in. So that's the age. And then we essentially want a new line, so we'll do new line. That is a vector. And we'll just say that's the row. And we're going to push that in as well into the DSV structure. Now, does that compile? Well, that does, fantastic. So, what if we print this? I can show you if we print this DSV data structure. Let's see what we get. So yeah, here you can see that you can imagine that these are bytes on a file on a disk somewhere when it's encoded and you can clearly see that 31, which is the control character, ASCII control character that separates each of these different fields. And then at the end of it, you have 30, which demarcates essentially that that's an entire record. So we can see those values there. So that's a structure we've created. This is just as an example. Of course, we wouldn't do it this way. This would be loaded in from a file somewhere or over a network or however that's transmitted and stored or whatever. But this is just as an example. So now that we have that, we can let's just leave. Let's just comment out that we don't need that. That was just to display it. So let's say this is our records, if you like. So our records that we're parsing, we're going to call the parse method, and we're going to pass in the DSV. And then let's so imagine we've got this data which is from a disk or a network or wherever, and now we're going to parse that, and hopefully we should get a bunch of records back. And once we have that, we can hopefully print that. So let's have a look what happens. Let's see if this compiles and works. Fantastic, and there you go. There you go. So we can see that the actual parsing is working, and here's the actual structure that we get back. We've got a vector, if you like, and there could be, obviously, if we sort of extended this, you could imagine you'd have a whole load of vectors essentially, and each of those records, if you like, contain the different values. So Bob, we have Bob, which is age 23, and so forth. But that essentially, this demonstrates the ease at which and the simplicity of using ASCII control characters as opposed to using something ambiguous as sort of characters and new lines and all that kind of stuff, which could be very different based on which operating system and which encoder or which library and which encoder that you use, or what combinations of options that the encoder uses. And we remove all of that ambiguity because we're using a defined schema, a very well defined schema. And this is what solves, if you go back to here, this is what we mean by having a defined schema, to know explicitly what are the rules around encoding and what are the rules around decoding. And of course there are negative aspects of it in terms of, because it's a non-rendering character. For example, CSV, one of the ideas is that, quote unquote, it's human readable. You can open up a CSV in a text file and you can read it. Of course, if you try to do the same with what has been created using these ASCII control characters, that would not be the same thing, because they're non-renderable. So it would just look look like garbage text, essentially, all sort of mashed up text and data, all, and it would be difficult to parse, or we would not be human readable, essentially. That is the downside of it. But I think, to be honest, I think I would take that, because there's no need for us to sort of read it, open it in a text file to read it. There's no reason for that, because we have these control characters. It's well defined. It's ridiculously easy to kind of parse that, as kind of shown here, and because you have that explicitly defined, there is no confusion. You cannot get it wrong, essentially. So that's why I found this article by Matt Hodges. CSVs are kind of bad and DSVs are kind of good. I genuinely hope that as an industry we start dropping. It's very difficult. It is very difficult to sort of fight momentum because CSVs are so universal almost. But they do suffer from this, and the fact that we have these things about auto-detecting CSVs, or what kind of encoding are used in CSVs, that's a very massive, horrible band-aid that we're applying to a problem that can already be solved. And using defined characters. Now, I'm not saying we have to use these characters, but the fact that they already exist, it's already there. Why not use it? It's a very it's very difficult to argue why would you not use these control characters that are specifically designed for this. Why have we kind of gone for commas and new lines with all of the ambiguities across different operating systems? I don't know. Very good question. So yeah, we should probably start promoting DSVs because it would solve quite a lot of problems. Especially a lot of people who use data and are in the data science will be fully aware of all the pains and the hassles that they have to go through, and we can do much better. And certainly, I think it perhaps is an education piece where we need to start thinking about, instead of using this weird, instead of using this sort of ambiguous format, let's use a very well-defined structured, very well-defined schema such as DSV. So yeah, that is all for today's session. I hope you found it interesting. I certainly found it interesting. And until the next time, I'll see you on the next one.